what if our two best descriptions of reality are fundamentally wrong? I mean, we have these two incredible theories, one for the really, really big stuff and one for the tiny, tiny stuff. And they work perfectly. But here's the catch. They completely contradict each other. And that contradiction, it's like a giant crack running right through the foundation of everything we think we know about physics. So what is this mystery exactly? It's not just about some far-off concept like black holes or the Big Bang. No, this is something way more fundamental. It's this deep fracture, this fault line running through the very core of physics, a place where our best, most brilliant ideas just completely fall apart. And here's the problem, boiled down to one slide. On one side, you've got our theory for the cosmic scale. We're talking planets, stars, entire galaxies. On the other, our theory for the quantum world, the world of atoms and particles. And look, both of them are unbelievably successful in their own domains. But the moment you try to get them to talk to each other, the math just explodes. It goes haywire. It's a total mess. The bottom line is, they can't both be the final word. For decades, the absolute sharpest minds in physics have been trying to bridge this gap, to somehow unify these two powerhouse theories. But what if that's the wrong approach entirely? What if the solution isn't to fix them, but to just throw out some of our most basic fundamental assumptions about how the universe works and start over? From scratch? Now that is the radical idea we're going to dive into today. All right, so first things first, let's really get a handle on this conflict at the heart of modern physics. It's kind of like a tale of two titans that refuse to even get in the same ring. So in one corner, we've got Einstein's general relativity. This is the undisputed champion of the cosmic scale, right? It perfectly describes how planets orbit stars and how light itself bends around massive galaxies. And in the other corner, we have quantum mechanics, the super weird but ridiculously successful theory of the subatomic world. And these two champions, they absolutely will not play by the same set of rules. And this is the real reason they can't be unified. We're not talking about some minor disagreement here. Their foundational assumptions, their axioms, the very bedrock they're built on, are mathematically incompatible. They cancel each other out. You can't just tape them together. To make them work as one, you'd have to fundamentally break one or maybe even both of them. It's a genuine impasse, a dead end. Okay, so if unification is a dead end, what's the alternative? Well, this brings us to a challenger theory, a real dark horse, known as quantum geometry dynamics, or QGD for short. And it proposes a truly revolutionary, mind-bending starting point. The person behind this theory often points to this quote from Max Planck, one of the fathers of quantum mechanics. And it really frames the whole mission. The idea isn't to slowly convince your opponents. It's to propose something so new, so different, that it just bypasses the old debate completely. You start with a fresh perspective for a new generation. And to really get what's going on here, we have to be super clear on what an axiom is. Basically, it's a starting point. It's a fundamental assumption that you don't prove, but you use it to build and prove everything else in your theory. Think of it like the "we hold these truths to be self-evident" part of physics. So this new theory asks a really profound, almost heretical question. What if the most fundamental, unspoken assumption in all of physics is just plain wrong? And here it is. This is that radical new axiom in a nutshell. On the left, that's the standard view we all learn. Space is this smooth, continuous fabric that you can, in theory, zoom into forever and ever. But on the right, that's the core idea of QGD. It says space is discrete. It's made of fundamental, indivisible units. Reality isn't a smooth painting. It's more like a digital image on a screen. It has a final, ultimate resolution. It's pixelated. Okay, so if the universe is made of pixels, what are those pixels? And what's painting the picture that we see every day? Well, according to this theory, it all boils down to just two incredibly simple particles. So this new universe is built from just two things. First, you've got these preon negatives. And get this, they aren't in space. They literally are space. There's this fundamental repulsive force between them, and that's what creates the three dimensions we experience. Then you have the preon positives. This is the stuff of matter and energy, and they are always, always moving at the speed of light, c. And here's how it all comes together, how you build a universe from this. You start with this simple cosmic soup of these two preons. Their interactions then create everything else. The really key takeaway here is that particles we thought were fundamental, like photons and electrons, aren't. They're actually composite structures, kind of like molecules, built from these two even more basic ingredients. It's like finding out your Lego bricks are themselves made of even smaller Lego bricks. All right, having a new set of building blocks is cool and all, but any new theory worth its salt has to explain the big stuff. So, how does this pixelated model handle a giant like gravity? This is where things get really, really interesting. This table just lays out how wildly different the two views of gravity are. You've got general relativity, which describes this beautiful dance where mass tells space-time how to curve, and that curve tells mass how to move. QGD just throws that whole picture out. It proposes a dual force. Matter attracts other matter, while space, the pixels of space, repels other bits of space. And here's the craziest part. It claims this force doesn't travel through space at all. It's instantaneous. That is a complete break from Einstein's model. But okay, can this new model actually work in the real world? Well, the first big test is always Mercury's orbit. General relativity famously explained its weird little wobble perfectly. And, according to QGD, its dual force model can reproduce that exact same prediction. But it does it without needing any of that weirdness like curved spacetime or time dilation. Okay, so reproducing old successes is one thing. That's the price of admission. But a truly great theory has to do more. It has to explain things the old theories can't. And this is where QGD makes some of its boldest claims, by tackling the biggest mysteries in all of cosmology. First up, dark matter. You've heard of this, right? For decades, we've been hunting for some mysterious, invisible particle that seems to make up most of the matter in the universe. We can totally see its gravitational effects holding galaxies together, but we just can't find the stuff itself. So what does QGD say it is? And man, the difference in approach is just stark. The standard model is looking for some brand new, exotic particle we've never seen before. QGD says, hold on, you don't need one. In its view, what we call dark matter is simply the combined gravity of all the free-floating preon positives that haven't clumped together to form atoms yet. It's not some new discovery waiting to be made, it's just the leftover building material of the universe, hiding in plain sight. Next up, dark energy. This is the placeholder name we give to whatever is causing the expansion of the universe to speed up, which is a really weird finding. The standard model suggests some mysterious energy that's just part of space itself. But QGD offers another wild idea, and it stems directly from its weird dual-force gravity. It claims that while gravity is attractive up close, when you get to vast cosmological distances, the cumulative repulsion of all the intervening space pixels actually starts to overpower the attraction between galaxies. Gravity itself flips and becomes repulsive, pushing everything apart. Okay, bold claims are one thing, but this is science, and science demands proof. A theory, no matter how beautiful or elegant it is completely useless if you can't test it. This is the final and most important hurdle. Can it make unique, falsifiable predictions? And here is where the rubber really meets the road. QGD puts its neck on the line with 4 huge, testable predictions. First, gravitational waves, as Einstein described them, they don't exist. The signals our detectors are picking up are something else entirely. Second, and this is a total mindbender, the one-way speed of light is not actually constant. That would just upend a century of physics. Third, gravity gets massively, massively stronger at the tiny nuclear scale. And fourth, black holes aren't singularities. There's no infinite density. They're just extremely dense, finite objects that eventually radiate their components back out. Each one of these is a direct challenge to mainstream physics. Each one could prove the theory wrong. So we're left with this radical new picture of the universe. It's not a smooth canvas, but a cosmic digital screen made of pixels. Could this be it? A true revolution in physics? A new foundation built from just 2 simple particles? Or is it just a fascinating, elegant dead end? The only way we're ever going to know for sure is to test these predictions and see if reality actually matches the model. The answer is out there, somewhere, just waiting to be found.